Today we're going to be reviewing factoring and using the zero product property. So the steps in order to do this is you want to get the equation equal to 0. Then you're going to factor by, again, always look for GCF first and then keep factoring after that. After it's in factored form, you're going to set each factor equal to 0 and solve. So let's go ahead and practice this with number 1 here. We're going to move the 69 to the other side along with the 4x in order to get this equal to 0. So we get x squared plus 16x plus 64 equals 0. We're going to go ahead and factor this. There's no GCF. So since our a value is 1, we're going to do our shortcut. We're going to look for what multiplies to get 64 but adds to get 16. Those numbers would be 8 and 8. And again, if you want to do split middle term, you can, but I'm just going to jump to the shortcut. I can do that because my a value is 1. So we're going to write it as x plus 8 and x plus 8. We're going to set each factor equal to 0, and we're going to solve each one. So we get x equals negative 8 and x equals negative 8. Let's try number 2. Again, we're going to get everything equal to 0, so we're going to add x squared, we're going to add 2x, and we're going to subtract 6. So we're going to get 3x squared plus 3x minus 6 equals 0. So we're going to factor, but as again, a reminder, you always look for your GCF first. All of these have a common factor of 3. So when we divide the 3 out of each of these, we get x squared plus x minus 2 equals 0. Then we're going to continue to factor this inside part. So we are looking for what multiplies to get negative 2, but adds to get a positive 1. It's going to have to be 2 and 1, and the 1 is going to have to be negative in order for both of these to work out. Again, you can do split middle term, but because my a value is 1 for this one as well, I'm going to just write my factors as x plus 2 and x minus 1. Step 3 is to set each factor equal to 0 and solve. So I'm going to do 3 equals 0, x plus 2 equals 0, and x minus 1 equals 0. And you might be saying, well, wait a second, 3 equals 0, that doesn't make sense. This does not work. There's no x with it, so there's no answer for that one. So you just cross that one out and say not true, doesn't work. For the other two, you subtract 2 and add 1. So our answers here are x equals 2 and x equals 1. Let's try one more here. Let's go ahead and add x cubed and subtract 2. So we get x cubed minus 11x squared plus 18x equals 0. Notice it's written in standard form. That's going to make it nicer to factor. I'm going to factor first out a GCF. Each of these have an x in common. So I'm going to divide them each by x to get x squared minus 11x plus 18 equals 0. We're looking for what multiplies to get 18, but adds to get negative 11. So in order for this to work, they both have to be negative. And so negative 9 and negative 2 would multiply to get 18, but add to get negative 11. So I'm going to write this in factored form, remembering to bring my GCF with. So I have x, and then x minus 9, and x minus 2. I'm going to set each part equal to 0, and I'm going to solve the resulting equations. For my first one, I do get x equals 0. The next one, I get x equals 9. And lastly, x equals 2 when I add those to the other side. So that's the gist of it. What I'd like you to do is go ahead and try 4, 5, and 6 by pausing it first. And then when you're done, you can come back here to listen to the explanation. So once we've gotten everything to one side for this one, you should have ended with 2x squared minus 12x minus 54 equals 0. If you're saying where does that come from, try to show the work of moving everything over. So you should show minus x squared and minus 13x. All of these have a GCF of 2, so if you continued on from there, you should get 2 out in front and then x squared minus 6x minus 27. Where here we're looking for what multiplies to get negative 27 and adds to get negative 6. Your numbers would be negative 9 and 3. So we're going to bring the GCF with, we're going to write x minus 9 and x plus 3, and set each of those parts equal to 0. 2 does not equal 0. That does not give us a solution. So our only answers are x equals 9 and x equals negative 3. For this next one, same thing. We moved the x to the fourth to the other side. When we subtracted x cubed from both sides, those actually cancel each other out. So we're left with x to the fourth minus 16x squared equals 0. So we are going to take out a GCF. They both have x squared in common. And when we do that, what's left behind is actually the difference of two squares. So it's a different factoring method. So I'm going to bring my GCF with. The difference of two squares means that if I square root the first term, I get x. And if I square root the 16, I get 4. We're going to write one with a plus and one with a minus. Then set each factor equal to 0 and solve. So our first one, x squared equals 0. You square root both sides, you get x equals 0. The next one you subtract 4 from both sides, and the last one you add 4 to both sides. For this next one, when you move everything over to the other side, you're going to end up with a polynomial that has a coefficient. So you get 8x squared minus 2x minus 3. Now here's no GCF, so here's where we have to do split middle term. So we're going to be looking for what multiplies to get negative 24 and yet adds to get negative 2. So your number should be 6 and 4, and the 6 has to be negative to make this work. So we're going to bring down the 8x squared. We're going to break up the next one to minus 6x and plus 4x. And we're going to bring down the minus 3. You chop this in half and see what the first two have in common. They have a 2x in common. So you're going to divide that GCF out. You will get 4x minus 3. The next two don't have anything in common, so we're going to divide out a GCF of 1 when that happens. Since our parentheses are the same, one of our factors is 4x minus 3. The other factor is 2x plus 1. We're going to go ahead and set each of those factors equal to 0, and we're going to solve the resulting equations. So you're going to add 3 and then divide by 4. And the other one, you're going to subtract 1 and then divide by 2. So our answers should be 3/4 and negative 1/2. So that's the idea of solving with factoring. Sometimes you're going to have to do a little bit more work in order to get everything to one side. So notice how we have parentheses here. These are not in factored form. They're in a form where we actually have to distribute first and then do everything we've been doing. So x times x gives us x squared. And then we have 3 times x. On the right-hand side, we have 5 times x and 5 times 7. Once it's distributed, now it looks exactly like the past examples. So now here's where we'll go ahead and get everything on one side. We get x squared minus 2x minus 35 equals 0. From here we can continue on our path. We're looking for what multiplies to get negative 35 and adds to get negative 2. 5 and 7 work if the 7 is negative. So we're going to write x plus 5 and x minus 7. Once it's factored, you're going to set each factor equal to 0 and finish solving those equations. So subtract 5 from both sides and add 7 gives us our final answers of x equals -5 and x equals +7. So let's try this next one. Same idea. We distribute to get 3x cubed minus 18x squared. On the right-hand side, we get 3x squared minus 30x. We're going to move everything to the one side to get it equal to 0. So we get 3x cubed minus 21x squared plus 30x equals 0. To factor, you always look for a GCF. These have a 3x in common, so we're going to factor out that 3x to get x squared minus 7x plus 10 equals 0. We're looking for what multiplies to get 10 and adds to get -7. So for these ones, they're both going to have to be negative, and 5 times 2 is 10, and then 5 plus 2 is 7, and if they're both negative, then it makes it work out. So we're going to carry on our GCF. We're going to write x minus 5 and x minus 2. We can again do this because your a value here is 1. You're going to set each of these factors equal to 0. And you're going to solve the resulting equations to get 0, +5, and +2. Okay, last example here, same process though. So 5x to the 4th plus 25x cubed. Distribute the other side to get 5x cubed minus 20x squared. Get it equal to 0. Oops, I changed that to a 2. We get 5x to the 4th plus 20x cubed plus 20x squared equals 0. Factor by taking out a GCF of 5x squared. We get x squared plus 4x plus 4. We're looking for what multiplies to get 4, but adds to get 4 as well, which would be 2 and 2. So we're going to write 5x squared and then x plus 2, and x plus 2 equals 0. Set each factor equal to 0 and solve the resulting equation. So divide by 5, square root both sides. Our answer should be x equals 0, x equals -2, and x equals -2. So that's the gist of these. Get everything equal to 0, factor by taking out a GCF, and then continuing to factor after that. Set each factor equal to 0, and then solve your resulting equation. Thanks for listening.